one of the reasons why you'd use a composition is, let's say you're in a science class and you're keeping track of bacteria on a turkey sandwich. So when you look at this, the two functions that are in the problem, this one records the number of bacteria on something, and then this one is a temperature equation. So as you go through an experiment, you know, you're sitting in class, you might run an experiment for 60 minutes, and maybe your teacher says, you know, you're going to calculate temperature or keep track every 5. So in an hour, you would plug in every 5 minutes, you know, you'd plug that in 12 times in one experiment. And then you take that and plug it into this number of bacteria 12 times. And so you're actually making 24 calculations in just one experiment. But the idea is if we do a composition, so we're going to take the temperature function, which is this guy, we're going to drop it into the number of bacteria equation. So maybe I'll do red. So it's 20, and instead of, you know, it says big T squared, so we're going to put in 4t plus 2 there. Then we're going to do minus 80, and again, instead of making the calculation to get the number, we're going to put in 4t plus 2 there, and then it's plus 500. So the idea is you have to take how many minutes the sandwich or whatever's been out of the refrigerator to calculate temperature. And then once you know what the temperature is of that sandwich, then you can plug it into the number of bacteria. So it looks a little complicated, but that's 16t squared. When you do the outside and the inside, you're going to have 2 times 4t and 2 times 4t, which is 18, 8t, which is 16t, plus 4 minus 320t minus 160 plus 500. 4t plus 2. If you take 4t plus 2 times 4t plus 2. 4 times 4 is the 16t squared. 2 times 2 is the 4. But on the OI, I was saying it's 2 times 4 and 2 times 4. So you're going to have 8t for the outside, 8t for the inside, 16t. Now multiply by 20. 20 times 16 is 320t squared. 20 times 16 is 320t. 20 times 4 is 80 minus 320t minus 160 plus 500. Oh, no, there. So the result is this 320t squared. That's 580 minus 160, which would be 420. Now this is a simplistic look at it, but the idea is, why would I need, you know, if the teacher says every 5 minutes, calculate what your temperature is, and then tell me how many bacteria you have, well, I don't need to worry about the temperature because I took the temperature function, dropped it into the number of bacteria function that we had. So really, every time they say calculate the bacteria, I just say, you know, spend 5 minutes, plug it in there, and it'll tell me. So the number of bacteria after 2 hours, I guess you could do it this way. 2 squared is 4, times 320 is that 1280? 1280? Yeah? Plus 420? 1700? Can somebody verify that, please? So I don't look like an idiot on the video later on. Okay. So you got 1700 yummy bacteria on the sandwich after just 2 hours. That's what gives it that good flavoring, people. The time when the bacteria count reaches 2,000. So now we're going to go 320 t squared plus 420. When does that equal 0? When does that equal 2,000? And maybe this is when you know that you're going to make people sick if you serve them that sandwich, right? Maybe 2,000 threshold. What are you going to do?
Subtract 420.
Do what?
Subtract 420.
Sure. Subtract 420. So you get 320 t squared is equal to, what, 1580? Divide by 320 on both sides. Can somebody give me that number? 1580? Or something, right? 4.93. Then you will square root. Don't forget your plus or minus. What's the square root of 4.93? Now, in this experiment, does it make sense to carry along the -2? What would that mean? We're running the experiment. Where is our turkey sandwich at -2 hours? Still in the refrigerator, still being made, right? I mean, it hasn't been sitting out on the counter yet. So in experiments, we're not concerned about the negative, so we would get rid of it. So about 2.2 hours. So the idea is, you work at a fast food restaurant or something, you can leave a turkey sandwich out for 2 hours, but after that, you have to throw it away because somebody's going to get sick.